dividing polynomials, and synthetic division. By the end of this video, we should be able to divide polynomials together. We should also be able to evaluate polynomials using the remainder theorem. All right, well, let's talk about polynomial division. Polynomial division is long division for polynomials, and you guys have done long division before. Let's check this out. So right here is an example of polynomial long division, and to the right is an example of long division that you learned in grade school. They are pretty much the exact same thing, so let's walk through these. We're right here to the left, we have 2x squared minus 5x minus 1. That is a polynomial, a trinomial, divided by x minus 3. So it's divided by a binomial x minus 3. And to the right, we have 253 divided by 7. And we're going to see how these things are almost exactly alike. The polynomial division is just a little bit different because we're dividing letters and we're using polynomials instead of numbers. But let's see this. So the first thing that you learned how to do when you learned how to do regular division with numbers, so you took the 7 and you divided it into 25. It doesn't go into 2, so I skip over to 25. And then I saw that it goes in 3 times. So let's do the same thing over here. But this time we just take the x. We ignore the 3 for a second, or the negative 3 I should say. We take the x, and we see how many times it can go into 2x squared. Well, x goes into 2x squared 2x times. The reason is because x times 2x is 2x squared. So we write 2x right up above, just like we did over here with the 3. 7 goes into 25 3 times. The next thing that you did with numbers is you went 3 times 7 is 21, and you wrote it below. So let's do the same thing. Let's take our 2x and multiply it by the divisor right here. 2x times x is 2x squared. Let's also do it to the negative 3. 2x times negative 3 is negative 6x. So now we have it written down below. Well, let's check this out. Let's look over to the right. We have 25 and 21. What you learn to do is you learn to subtract. 25 minus 21 was 4, and then you drop the 3. So let's do the same thing. Let's subtract over here. 2x squared minus 2x squared is 0. Now this part's a little bit tricky. Negative 5x minus a negative 6x, that's actually just a 1x. A lot of people would make a mistake and put a negative 11x, but that would be adding. Negative 5x minus a negative 6x is basically negative 5x plus 6, and that is a 1x. And then we drop the next number, which is negative 1. We're going to drop that down. So we have 1x minus 1. So now let's see what we're supposed to do. So over here to the right, I've got 43. So I see how many times does 7 go into 43? Well, it goes in 6 times. So I write 6 up above. So let's do the same thing over here with polynomials. Let's see how many times that x can go into 1x. Well, it just goes in 1 time, because x times 1 is 1x. So we write the 1 up above. And then we're practically done. Check this out. Let's look over here to the right. So I have that 6 up above. So what I would do is I would go 6 times 7 is 42, and I write that down below. So let's do that over here with the polynomial division. 1 times x is just an x. 1 times a negative 3 is negative 3. So I write that down below right here. I've written it in blue. And now let's check this out. We just subtract just like we did before. Over here to the right, I have 43 minus 42 is 1. I don't add those together. I subtract. So I do the same thing over here. I subtract. 1x, take away an x, is 0. Negative 1, take away a negative 3, that is a positive 2. So that is our remainder. Just like we had a remainder of 1 over here with numbers. So let's just analyze our answer. Right over here to the right, my answer is 36 remainder of 1. Well, how do I handle the remainder? Well, there were a couple ways. Sometimes you would just add a decimal and you would keep going, but you could write it as a fraction, as 36 and 1/7, because you would take that remainder and you would write it over 7. So we could do the same thing over here. So with the polynomials, my answer is 2x plus 1 with a remainder of 2. Well, how do I handle the remainder? I could just write it as a fraction. 2x plus 1 plus 2 over x minus 3. I know that's a little tricky and a little weird, but it's pretty much the same thing that you learned when you were in grade school when you just learned how to do long division. It's the same idea. Obviously, it's a little bit different because we're dealing with polynomials instead of numbers, but it's pretty much the same idea. All right, let's talk about synthetic division. This is actually just a shortcut. So it's a shortcut for what we just learned. So you might like this a little bit better. So here's an example of doing a problem with long division. Here's an example of doing the same problem with synthetic division. And we're going to talk about those in just a second. Let's look at the definition of synthetic division. So it is just a shortcut method for polynomial division when dividing by a linear binomial. That's the key. You have to be dividing by a linear binomial to do synthetic division. In this case, we do have a linear binomial because x minus 2 is a binomial and it is linear. So let's go ahead and talk about these. So doing long division, this is the way we do it right here. We have x cubed plus 2x squared minus 5x minus 1 is being divided by x minus 2. So let's just go ahead and talk about how we do that. So just like we did up above, x goes into x cubed, x squared times, and we write that up above. And now I just multiply down. X squared times x is x to the third power. X squared times a negative 2 is negative 2x squared. And then I just subtract. So I have x cubed minus x cubed is nothing. 2x squared minus a negative 2x squared, well, the minus a negative is going to turn that into a plus, so I'm actually going to have a 4x squared. And then I drop the next number, negative 5x. And then I just divide again. X goes into 4x squared, 4x times, because x times 4x is 4x squared. So now we just multiply down. 4x times x is 4x squared. 4x times a negative 2 is negative 8x. And now we just subtract. 4x squared minus 4x squared is nothing. Negative 5x squared minus a negative 8x squared. Well, the minus and the negative is going to turn into a plus. So it's basically negative 5x plus 8x, and that is a 3x. And then we drop the next number, which is a negative 1. And now I just divide again. X goes into 3x 3 times. So I write 3 up above. And now I just multiply down. 3 times x is 3x. 3 times a negative 2 is negative 6. So I subtract. 3x minus 3x is nothing. Negative 1 minus a negative 6 is a positive 5. So here's how we analyze this. My answer is x squared plus 4x plus 3 with a remainder of 5. The way that I can write the remainder is 5 over x minus 2. But that is my remainder is 5. So now let's look at synthetic division, doing the exact same problem. It's right here to the right. You can see there looks like a whole lot less to do. It looks a little bit easier. I think most students like synthetic division better. Maybe you will, or maybe you'll like long division because you've been doing it a long time in grade school with just regular numbers. But let's talk about synthetic division. Here's what you do. You look at the x minus 2. And we take the opposite of the number. So it's a negative 2, so we just go ahead and write 2 as our divisor. I know that's a little bit tricky, but we're going to talk about why that is in just a second. But for our purposes right now, let's just go ahead and write the opposite of the number. So the opposite of the negative 2 is a positive 2. I write it right there. Now we just take the coefficients. So the coefficient on x cubed is 1. So I put a 1 right here. The coefficient on the 2x squared is 2. So I put the 2. The coefficient on the x is negative 5. So I put a negative 5. And lastly, we have a negative 1. So I write it right there. One important thing to point out is if there were any variables that were skipped, I would have had to have put a coefficient of 0. For example, if there was no x squared term, I would have to actually still put the coefficient of 0. That's a little bit tricky, but in the example video that I do next, I'll have some examples like that. So let's go ahead and do this synthetic division. So the first thing that I do is I drop that 1 down. So you can see that I have the arrow and I've dropped it down. I go 2 times 1 is 2, and I write that right here. And then I just add these two numbers together. 2 plus 2 is 4, and I write 4 right down below. And then I go 2 times 4 is 8, and I write it right over here. And now I just add these two numbers together. Negative 5 plus 8 is 3. And then I go 2 times 3 is 6. I write it right here. I add those two numbers together and I get 5. You can see that I have the exact same thing. Check this out. My remainder is 5, just like I had before. Look at the coefficients in the quotient for the long division. The x squared coefficient was 1, the x coefficient was 4, the constant was 3. That's the same numbers I have right here, 1, 4, and 3. I just have to know how to interpret it. So I have the exact same answer. So right here, if I put the letters in, I would have 1x squared plus 4x plus 3 with a remainder of 5. So this is a little bit easier way to do it. I think you'll probably like synthetic division better, but it's important to know how to interpret your answer because 1, 4, and 3 are the coefficients in my answer, so I need to write them out. I started by dividing a cubic equation, so my answer is going to be a quadratic equation, and that's why it goes down one level. So that's why I would have 1x squared plus 4x plus 3 with a remainder of 5. All right, let's talk about what else synthetic division can do for us. It gives us this thing called the remainder theorem. If px is divided by x minus a, then the remainder is equal to p of a. Well, we're going to see what that means in just a second, but first let's talk about it. Here's the example right here. I have x cubed minus 3x squared plus 2x minus 1 divided by x minus 3. I'm going to try to make sense of that remainder theorem. So let's go ahead and use synthetic division. So you can see I take the opposite of the negative 3 and I write it right there. I take the coefficients and I write them right next to it. So I have 1, a negative 3, a positive 2, and a negative 1. And then I just go ahead and use synthetic division. So I drop the 1, and then I go 3 times 1 is 3. I add those together, I get 0. 3 times 0 is 0. So I write that up in here. 2 plus 0 is 2. So I write that down below. 3 times 2 is 6. Negative 1 and 6 has a remainder of 5. Ironically, I have a remainder of 5 again. The remainder is not always going to be 5. This is just a coincidence. So my remainder is 5. So here's what the remainder theorem is telling me. That actually, if I substituted 3 in for the x's, I would get 5. So I would get the remainder. So it tells me this. F of 3 is equal to 5. So if you were given a problem, you could either substitute 3 in for the x's, and we'll do that right here, or you could use synthetic division. And that is why we take the opposite of x minus 3. Because if x minus 3 is a factor, then we know that 3 is a root. So that's how come we take the opposite. So let's check that we would get that remainder actually. Let's go ahead and do that. We have f of x equals x to the third minus 3x squared plus 2x minus 1, just like we had up above. Let's go ahead and figure out what f of 3 is. So we go f of 3. That means that we substitute 3 in for the x's. So I have 3 cubed minus 3 times 3 squared plus 2 times 3 minus 1. So 3 cubed is 27. 3 squared is 9 times 3 is 27. 2 times 3 is 6. And we have the negative 1. So 27 minus 27 is nothing. 6 minus 1 is 5. So f of 3 equals 5. And that was our remainder when we did synthetic division. So it's a little bit confusing, I know, but if you check out the next video, I'm going to do some example problems on it. It's going to make a little bit more sense. Basically, it's this. You can either use substitution, you can plug the value into the equation and figure out what it is, or you can use synthetic division to get the same answer. So check out the next video. We'll do some example problems on these, and I know it's going to make a lot more sense. Basically, you can do long division with polynomials or synthetic division. It's up to you. Or synthetic substitution is another way instead of plugging the value into the equation. Sometimes when you plug a value into the equation, it gets a little bit tricky, especially if the powers are large. Synthetic substitution, you can just use synthetic division. Whatever the remainder is the answer you would have gotten when you plug that number in. So check out the next video. It's going to make a little bit more sense, I hope, and good luck.